study about the metabolism of drug, okay, under pharmacokinetics of drug. So we are going to understand the pharmacokinetics of a drug, but before that I need to find my duster so that I can clean the board. Where is my duster? I think I lost the duster. I cannot find my duster. So whatever will be in front of my eye, that will become my duster. Okay. So this thing is even the lecture timing. Okay, whatever. So if we want to understand what pharmacokinetics is, now we need to understand the term pharmacokinetics. Pharmacokinetics clearly states that the action of drug, the action of body on the drug, Now, what type of action body can do on a drug? What types of actions body can do on a drug? The body can absorb the drug. The body can distribute the drug. The body can metabolize the drug. And the body can excrete the drug. Okay. The body can excrete the drug. Now, today we will discuss about metabolism. First metabolism, then we will discuss about absorption, distribution and other things. Okay. Now, actually I should start from absorption. But I will do it later. Okay. So first we have to understand metabolism, right? So what is metabolism? Metabolism is nothing but breakdown. Okay. Metabolism is nothing but breakdown or building up. Breakdown of a molecule or building up a molecule inside our body through some biochemical reactions. This is called metabolism. What is breakdown called? Breakdown is called catabolism. And what is building up? This is anabolism. Anabolism is basically the building up a molecule inside our body through biochemical reactions. Now, how drug is metabolized in our body, we are going to study it. We are going to study how drug is metabolized inside our body. So first of all, before metabolism, what happens or what should we know? Before metabolism, we have to know the major organ of metabolism. The major organ which performs metabolism is metabolism is our liver. The major organ which performs metabolism is our liver. Now, to reach the liver, the drug has to come in our systemic circulation. To reach the liver, the drug has to come in our systemic circulation, right? The drug has to come in our systemic circulation. Okay. Now, the drug has to come to our systemic circulation. हमारे systemic circulation, ठीक है, हमारा systemic circulation में ड्रग को आना पड़ेगा, उसके बाद ही इसका मेटाबॉलिज्म हो सकता है. तो क्यों, why the drug has to come systemic circulation to reach our liver? Now see, actually what happens, let us assume intestine. This is our intestine, suppose. Okay, this is our intestine. Now, the blood vessels around intestine, these are blood vessels around intestine. Okay. Now the drug is absorbed from intestine to systemic circulation. Now the systemic circulation, when the drug comes to systemic circulation, that implies that the drugs are coming in the blood vessels. Okay. After reaching the blood vessels, there is a system we call hepatic portal system. So through hepatic portal system, the drug comes to liver. So first the drug is absorbed in our systemic circulation. That is why we study absorption first. Okay. The drug comes to systemic circulation through absorption, and after that the drug goes to liver through hepatic portal vein. This is our hepatic portal vein. This is our hepatic portal vein, and the drug comes to liver. And in the liver, the drug gets metabolized, and then what will happen, we will see further. Okay. So here the topic that we are going to discuss about is metabolism. Now after metabolism, what will happen, this depends upon the drug. Okay. There are several things may happen after metabolism. We are going to study one by one. Okay. So after getting into liver, the drugs gets metabolized. Now only liver is not responsible for metabolism of drug. There are several other organs like our stomach, our kidney. Okay, our lungs also involved in the metabolism of the drug. Okay. Now we have to understand that metabolism is termed as biotransformation also. As I have already mentioned that metabolism is nothing but breakdown or building up, right? Breakdown or building up reactions, right? Breakdown or building up reactions. Okay. Now, why metabolism referred to as biotransformation also, we are going to study it. Okay. Now we are going to study why metabolism why metabolism is called also biotransformation. Why metabolism is called also biotransformation? We are going to study biotransformation. Now, not only breakdown of a drug or building up something from a drug is termed as metabolism. Metabolism is basically biotransformation. Okay. Now, what is biotransformation? Biotransformation is like there is a non-polar drug. Let us assume a non-polar drug A. It is a non-polar drug. It's a non-polar drug. Okay. Now, what we are going to do, we are going to change this non-polar drug into polar drug. Not we. This will be done by our body. Our body will change this non-polar drug into a polar drug. Now, the drug which was non-polar initially is polar now. Why? Due to some biotransformation reactions. Due to some biotransformation reactions that are responsible for changing non-polar A drug into polar B drug. Right? Now, the things which are non-polar likes non-polar. Now, things which are non-polar likes non-polar. Now, things which are polar, they like polar. That means like dissolves like concept, right? So, A is non-polar in nature. So, A is also lipid soluble. Why? Because lipid is non-polar in nature. Right? Lipid is non-polar in nature. And B is polar. B is polar. So, that is why it is water soluble, you can say. Now, we should not use the term water soluble. Okay, we should not use the term water soluble. Rather, we can use the term lipid insoluble. Okay, lipid insoluble. Lipid insoluble. Okay, so drug A is non-polar in nature, which was non-polar in nature, lipid soluble, gets converted into B, which is polar or lipid insoluble. Now, this whole process is termed as metabolism of the A drug or biotransformation of the A drug. Now, some reactions are responsible for this phenomena. These reactions are divided into two parts. We're going to study about these reactions further. But before that, we have to understand how many types of biotransformation may happen. Okay. Means, what is the fate of this biotransformation? What is going to happen after biotransformation of a drug? We have to understand those points. Now, first of all, we are going to study about the fate of biotransformation, right? So, first fate of biotransformation is number one is inactivation. What is inactivation? Now, we have some misconceptions that a drug, I don't know how many people have this misconception, but I had this misconception that a drug gets activated after metabolism. Always. I thought that a drug, I used to think that each and every drug gets activated after its metabolism. No, this is wrong. Drug may get inactivated also after biotransformation. which we going to study first, which are going to study first. Okay. What happens? Like, let us give an example of paracetamol. Okay, paracetamol. Or paracetamol. I actually forgot the mm active metabolite of paracetamol. So I am not taking the example of paracetamol. Okay. Uh, let's take the example of propranolol. 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 Okay, propranolol. Now this is a drug whose active metabolite, okay, whose active metabolites should be inactivated. This is a drug whose active metabolite should be inactivated. Let's see what is the active metabolite of propranolol is 4-hydroxy 4-hydroxy propranolol. Okay, 4-hydroxy propranolol. Okay, 4-hydroxy propranolol. Now propranolol is a drug whose active metabolite is 4-hydroxy propranolol. It is the active metabolite. Okay. Now this active metabolite is inactivated by is inactivated by biotransformation reaction. We'll later study that how biotransformation affects this reaction, but this is the active metabolite which may show adverse effect in our body. Okay, so this is inactivated by biotransformation reaction. Okay, like that the active metabolite of paracetamol also uh, inactivated by biotransformation because the active metabolite is harmful for our body, and through inactivation the drug excretes out through our body, from our body. Okay, the drug excretes out from our body. Okay, now next point is biotransformation not only inactivates the drug. Okay, biotransformation not only inactivates the drug, but also it activates the drug. How? Let us give an example of, I will explain the whole concept here. Okay, now the second fate of biotransformation is activation of বা making active metabolite from active drug, making active metabolite from active drug. Now you have to understand, making active metabolite from active drug. What does it mean? Here you can see both the words used here, active metabolite and active drug. So in this case what is going to happen is there will be an active drug. Let's say A is a active drug. Okay, it is active drug. What does it mean by active drug? Active drug means this drug is acting upon our body and is showing its pharmacological effect or therapeutic effect. Okay, this drug is active. Why this drug is active? Because it is showing a pharmacological activity in our body. Okay, now through biotransformation, when we are performing biotransformation, okay, biotransformation, this is the short form of biotransformation that I have written on this arrow. Okay, I have not written the whole word because it is time consuming. Okay, now through biotransformation, the active drug gets converted into some metabolites, right? Let us say P plus Q. P and Q are metabolites. P and Q are active metabolites. Not only metabolites, they are active metabolites. P and Q, active metabolites, right? And certain portion of drug will remain intact also. What I have said? Certain portion of drug will remain intact also. Means certain portion of drug is not going to be metabolized. Okay, so again understand properly. A is the active drug. Okay, now this active drug through biotransformation is converted into P and Q, which are active metabolites, and certain portion of drug still remains intact, which is A. Now you can see the metabolites are active also, and the drug is active also. The drug is active and the metabolites are active also. You can see it? Yes. And we can also see that the whole drug is not converted into active metabolites. Some portion of the drug still remains intact. This is the active drug which remains intact. This is the active drug. Now you can see the drug is also active and the metabolites are also active. That means the active metabolites and the drug have a pharmacological action. Okay, that means both the active drug and metabolites are working together. Okay, are working together means if I consider t is equal to 0, at which the drug is t is equal to 0, the drug has come to liver. Okay, I've considered the time 0 at which the drug has come to liver. Now the liver is biotransforming the drug from A to active drug and active metabolites. Let us assume the time t is equal to t. Now at t is equal to t, in my body active drug is present and active metabolites are also present, and both are active, so both are showing their pharmacological activity individually, and we are getting a cumulative effect of drug and metabolites. Okay, so this is the another fate of biotransformation in which active metabolite from active drug in which the active metabolite from active drug is made, where the drug and the metabolites working together to show some pharmacological effect. Okay, so we can say that the net therapeutic activity net therapeutic activity equals to, let us assume therapeutic activity therapeutic activity as T. We are just assuming therapeutic activity is T. So net therapeutic activity T equals to what can we say? That therapeutic activity of drug means therapeutic activity of A plus therapeutic activity of the metabolites. Okay, one of such examples are the conversion of digitoxin into digoxin. Now here digitoxin is the drug and digoxin is the metabolite of digitoxin. But both are working together to show some pharmacological effect. Okay, to show some pharmacological effect. Okay. Now the third one is that we are going to discuss. How much time is left? Let me see. Okay, I have only 5 minutes left, and within 5 minutes I have to explain the whole thing. Now next we are going to talk about the third point, the third fate of the biotransformation, which is activation of inactive drug. Activation of inactive drug. Now what does it mean by activation of inactive drug? Activation of inactive drug. Now here you can say activation of inactive drug means the drug is initially inactive. See properly. The drug is initially inactive. Let us assume drug A, which is inactive initially. Now through biotransformation, the drugs gets converted into B, which is active. Now here there is no cumulative effect of A and B because A is inactive, so it has no pharmacological action. But B has a pharmacological action because it is active. This is the point. Okay. Now this inactive drug is also called prodrug. I think you know about the term proinsulin. What is proinsulin? Proinsulin has 3 chains, right? One is A chain, another one is C chain, and another one is B chain. There are 3 chains in insulin, A, C and B. Now this is not insulin actually, this is proinsulin. When the C chain is removed from the whole insulin and the A and B chain joined, the A and B chain are joined to each other by disulfide bond, then it is called insulin. Okay. Then this is called insulin. Like that, when we are saying about drug, The drug which is inactive in nature is a prodrug, and which is activated, and this is, now the B is our drug. So prodrug gets converted into drug by biotransformation. Some of the examples are like levodopa converted. Okay, levodopa gets converted into dopamine, right? Levodopa gets converted into dopamine. So we can write that, we can write here, what we can write here, or what we can interpret here, that the net therapeutic activity in case of activation of a drug which was previously inactive. So net therapeutic activity will be therapeutic activity of drug, therapeutic activity of prodrug plus therapeutic activity of drug. Now we all know that A was the prodrug, so it has no pharmacological effect. So the pharmacological effect of this, or therapeutic activity of this prodrug, is 0. So we can write that net therapeutic activity is equal to TB. That implies that the net therapeutic activity of a drug during activation of a prodrug is equal to the therapeutic activity of the drug. Means prodrug is not important for our body, but it is needed to be converted into a drug through metabolism to show its pharmacological action. Okay, now next day we'll discuss about the different reactions that takes place in biotransformation. Thank you. Bye.